Cool. So, welcome. I know we're in the last day, and this is like one of the last sessions, so thanks for showing up. I want to start off a little different from some of the other talks. So first, how many of y'all have experienced frustrations with data changes? Like just, yeah, everybody, right? And how many times have you had like difficulties just tracking your data, your models, all your experiments? Like, is that something everybody can kind of relate to? Cool. So that brings us to pretty much why you're here today. You have a need to keep your models in production fresh. And we all know what kind of weird, crazy things happen when our models go stale. So today I'm going to talk to you about how you can prevent that from happening just by using some MLOps tools, and we'll walk through the whole MLOps pipeline. But my name is Milecia McGregor. My background is literally all over the place. I have my master's in mechanical and aerospace engineering. And then I did robotics and machine learning for a while, front-end, back-end development, DevOps. It's been a ride. But I want to start with one thing in particular. Just so you don't have to worry about taking pictures of slides you're interested in, here's a link to the whole presentation right at the beginning. So, thought that might be useful. Okay, so now we can actually jump into the topic today. First, we're going to start by defining our business problem, because we need a really well-defined problem, right? So, we're going to pretend today that we work for a bicycle company, and they need to know when and where to move their bicycles. So we have some data that corresponds to the weather, cyclists' behavior during the day, maybe some events that are going on around the time that they're trying to move these bikes around. So we have our whole MLOps pipeline here, very simple one. And we're going to start at the very beginning and walk through to the end during this talk. But keep in mind, we're looking at those bicycles, like where and how many do we move around to different locations. So let's start with our training, the initial version of training. We get some data, and this might feel familiar. You get some CSV files, you get some stuff from a database where there's a bunch of columns that have null and zero values, and it's up to you to figure out how to make something useful out of that data and get it into a format that's usable for your training. So you might do something like this, where you have a Google Drive with a bunch of zip files, and you have a spreadsheet associated with all the metrics for these different models. Maybe their data sets are in the zip drive. Sometimes, it turns into a mess to manage all of those different experiments and keep up with the data sets. And that leads to a lot of sadness, because people spend so much time on these experiments, and now you don't know what data set you used, or you don't know which hyperparameters you used. So we're going to fix that with DVC, which I think everybody's heard a lot about during this conference. But DVC is like get, but for data. So after you go through, you clean up all your data, maybe you start on your feature engineering, and you decide, yes, this is the data set that I need to share with all of my coworkers. This is what I'm going to use to start my experiment training. So we're going to take this, and we're going to take our nice cleaned up bicycle data, and we're going to push it up to an S3 bucket. So you can use DVC push to take the data from your local environment or wherever you're training. It's stored in the cache so that as you're deciding what to do with this data, whether you want to keep it or not, it still has that local version for you. And once you decide, this is what I want to push up because I'm proud and everybody should see how good I did cleaning this data, you push it up from the cache to whatever cloud storage you're using, an S3 bucket, Azure Blob Storage. Maybe you're just attached to Google Drive and you want to keep pushing it there. It's totally fine. So we've decided we're going to take this data set, push it up to a remote, and I want to make sure you really understand like how DVC and Git compare. So we know Git is for developers who write code, features, bugs, bug fixes, whatever. So they write their code locally, they push it up to some remote place like Bitbucket, GitLab, GitHub, and you can pull down these different commits, these different versions of code. DVC is the exact same, except instead of pushing to GitHub, maybe you push to AWS. And instead of front-end or back-end developers, maybe you share with your data scientists and ML engineers. So this is how DVC fits into that overall MLOps flow. We use it to version the data as well as run experiments, which I'm going to show you in a second. So right now we have our data cleaned up. What's in the script really isn't super important, but this is when we get to the training stage, right? So we have some Python script that's doing something, using some kind of algorithm, some hyperparameter values, and this is the part we want to focus on here. So not really super focus on, but we're using a random forest classifier to figure out if we can make a good model to predict our bicycle locations and the amount that we need in those different locations. So this might look kind of familiar. You have your algorithm, you have the hyperparameters. Maybe they're in the file, maybe you make a commit every time you tune them. But if you're using something like DVC, you have this params file that you see over there, where you just define what your hyperparameters are. You can write a script to just automate that, run all those experiments and track them, and you get this. So this is a little snippet of what experiment tracking looks like in DVC. So every time you make a change to your data, your code, or your hyperparameters, DVC tracks that. So as you can see, we have several experiments here. We're trying to figure out which one of these experiments gave us the best production version of the model. So we're going to look at our stats like the average precision, that AUC value, and you can see the hyperparameters associated with each experiment. So this is just a small snapshot of what you can see. You can, of course, check out like the data version you're using and a number of other hyperparameter values. But in our particular example, it looks like, what is it? The third one from the bottom is probably the best experiment. So that's probably the model we want to deploy. It's got some pretty good stats, some good metrics, but just to make sure, we're going to make a pull request for this, and we're going to share it with our colleagues and compare branches and commits. So we have another tool that's called Iterative Studio, where you can share all of the experiments you've run in a particular Git repo, and you can go through this UI and decide which commits, which branches you want to compare metrics between. So here, we're just looking at a couple of experiments, and you pick which one you think is good enough for production, and then we deploy it. So we are finally in the second stage. All of that just to get to the second step, right? So we finally have that great model. We've gone through our whatever acceptance criteria. We've validated that it makes sense. And now we're going to deploy it using an API. So again, the big block of code doesn't matter that much. It's just showing that we are using that model we trained. So this is some endpoint in a Flask app, and we're importing our model, which is right now located inside of the project. So we're just pulling that in, and we're running predictions. That's it. Everything is good. There's peace in the world. The bikes are getting delivered where they need to be, and all of the citizens are happily riding through the city. So a little context, I'm from Oklahoma. We don't ride bikes there. And learning actual bicyclist behavior has been interesting. I didn't know y'all ride bikes in the rain. But we figured all of that out, and we're sending the bikes to the subways, to the grocery stores, wherever, and everybody's good. The business side is happy, nothing is wrong. And we're just gonna monitor, like everything is good right now. So we're just gonna keep an eye on this model, make sure everything's good to go. And then we get those new insights. So now our beautiful, perfect model has started to deviate. Now we're starting to see different kinds of drift. This is where things get really fun for us. So what is the problem? What has changed? Is it just the data quality? Like, are we still getting the same columns? Are we still getting the same types of data? And now we're just seeing a lot of nulls and zeros? Is it concept drift, where now the company has electric bicycles, so the thing that we were trying to predict initially is different? Or is it data drift, where now people are, I guess, picking up Oklahoma bicycling behaviors, and that's completely throwing off where they need to take these bikes, when they need to be there, and we're trying to figure out how, where, what is happening. So what we do is take a look at some statistics around it. So in the case of our data, maybe there's a certain handful of columns that are really different from what they used to be. So instead of getting a numeric value, for whatever reason, we're getting a Boolean. And we notice that difference between our reference data set and the data that we're currently pulling in from production. That means, unfortunately, our predictions are a lot less accurate than they were at first. So in the beginning, everything was great. Like, that's exactly what we wanted. It was predicting what was happening in real life. And here we are. It's not there anymore. So now instead of sending 100 bikes to some subway station around rush hour, we're sending 72 of those to some random place by the airport. So I don't think people ride bikes from the airport, but y'all could probably correct me on that. But the point is, now our predictions are way off. This is having actual business impact, and it's not time to panic, even though this is probably when people will be panicking. But we're not going to do that. Because even though our predictions are out of sync with the current data, and we've sent those bikes to the wrong location, it's okay. It's fine. We're just going to tell everybody to calm down for a little bit, and we're going to get this new data from production. So we are actually getting ready to start like this new cycle of going through that pipeline. So we're going to use the other part of DVC where we pull down data from a remote to our local machine. So in this case, Maybe somebody on the data team has uploaded a new CSV, or they've given us access to some other data resources. But this is just what that might look like in a cloud environment. But now that we have this data, we're going to retrain the model, right? So we're going to run new experiments to get updated models. We're going to check the metrics between these experiments, just like we did before. And maybe you can see where some of that automation might start to come in. So you might have a particular metric you're monitoring, like the average precision or that AUC value. And once you reach a certain threshold, you decide this model is good enough to go to prod. So just throwing that out there, some places you might throw in automation. But once you've run these experiments, you've compared notes with your colleagues, and you all decide that this is the next great model, we're going to get this one out to production again. So we do that. This time we're going to bundle these last two steps together just so we know that they kind of go hand in hand. But some of the things you might decide to monitor when you're looking at drift are like the AE outlier score. So if you remember when we had that prediction graph up here, how all of those data points slowly spread and a lot of them became outliers. Then we have the KS drift. That's another statistical measurement that we use to see how far off the data is from that reference data. And of course, we have our data drift, where again, we're like, well, maybe the patterns of bicycle riders have changed, and we need to account for that. Same with concept drift. Everything's slowly becoming electric. So instead of having manual bikes, now our company has electric bikes. Maybe they've thrown in some scooters, maybe skateboards, I don't know. But we're trying to predict something different from what our model is trained on. And then, of course, we have the prediction drift. So that is just like we saw in that graph earlier, when our predictions start to fade away from what actually happens in the real world. So these are just some of the things that you can monitor. It's not like a super exhaustive list or anything I picked on purpose. They just come up a lot. But those are some of the things you'll monitor for, all statistically. And the tool that I decided to use for this little project was Evidently.AI, but there's also a bunch of other tools which I'll get to when we talk about the additional resources, but I know Aporia is one of them on the list, and I know they're at least at the conference somewhere. But this is just a snippet of the code you might write to actually monitor those drifts. So we have our category drift, and we have our data drift. So with that being said, really, really fast, let's wrap up with some key takeaways. So the first thing, we all know that switching between data versions is a super common challenge. Like, I'm pretty sure some of y'all saw the Google Drive folders and immediately thought about what you do. So you don't have to do that. Just try out some of these open source tools, some of the tools that are around here. But of course, you should always check out DVC because we're totally open source and we track all of your data, no matter how small the changes are, no matter what remote you're using. And again, we actually do experiment tracking too. So if you're using MLflow or something like that, you could not and just use DVC. It's all wrapped up in one tool. And then the last thing that, after talking to a lot of y'all at this conference, I'm pretty sure you already know how MLOps makes everything easier, but it's just one of those areas. Really think about ways that you can automate things because it's so new that there's a lot of stuff you can just try. So don't ever be afraid to try new tools, try new strategies, just do stuff. There's best practices, but are they the best? It depends. So, last couple of things I want to leave you with are just some resources. If you are interested in DVC, check out our docs. They'll get you up and running really fast. If you want to get into some really nitty-gritty technical details, reach out on our Discord channel so you can talk directly to the engineers working on these open source projects. And then we have a completely free online class. So it's only about 4-ish hours, and it'll walk you through setting up DVC, some of those MLOps best practices. If you're not familiar with using Git, it'll introduce you to that. So it's a lot of goodness packed in there. And then again, here's a link to the slides if you need that, because I know that's super important to people. I always end up taking a bunch of pictures of slides too. And finally, some useful tools. Even though there's a ton of them literally across the hall, this is just a small list that I came up with for monitoring, because that's one thing DVC doesn't do yet. But I digress. So evidently AI, that's the example that I used today. Aporia, they're another great tool, which again, I'm pretty sure they have a booth somewhere still set up. And Ravella, I saw them earlier. I talked to somebody from them earlier. Yes. And then another open source tool, Scikit. If you use scikit-learn, there you go. It's just like a little extension. So that is actually all I have for you today. Do y'all have any questions?
Hey, it is a continuation of the question about the 5 terabyte data. For example, the scale is a little larger in one magnitude, maybe 50 terabytes or something. But the issue is the file sizes are quite small. That is maybe just 10 kilobytes of sizes. And that makes the number of files quite large. As when we see even 10 TB is not that huge when we talk about big data. But when the file sizes are too small, that is kind of considerable more amount of files. So how does DVC have? Because that becomes a lot of hashing for individual files. It takes a lot of time as well.
I mean, if you have a lot of files, DVC can track entire directories. So you could just put them all in a directory and it'll track the differences that way. So you don't have like these separate hashes for small changes in a file, if that makes sense. Instead, it'll track the changes for the directory.
Okay, I mean, we were working with the workflow where it was done on Minayo. So Minayo was handled in-house and on-prem solution. So yeah, we had some directory structure, but still they were huge. I mean, still the directories were like at least 60, 70 GBs. So still, I mean, we didn't want that much to be on the same hash, right? I mean, you would want to have individual, at least some more granularity. So any other solutions you might recommend in that case?
That's actually something else I would have to think about. If you want to hang out afterwards, I can talk about it with you more.
Sure, definitely. Thanks.
That's a good question. Y'all are coming with some really good ones this time.
Nice. It was a great talk. Thanks a lot.
Yeah.
Thanks for the talk. It was really good. I have a question because we have some workflows where, I mean, the input is usually a query into our data lake. And then like you kind of, that ensures that it's replicable because the query, if you do it properly, you get the same data, but then it takes some time. But how long, I don't know, like how much time takes to kind of migrate to DVC for this existing? I don't know, this is the workflow we have in some projects right now. So I'm thinking how much time could take to migrate to DVC.
So it actually shouldn't be that hard to migrate because DVC is just a command line tool. So all you do is initialize DVC in your project, connect it to whatever remote that you're using, and start to push and pull data that way. But that's really it for setting up DVC.
Okay, cool. Thanks.
No problem.
Hi, Milecia. I like the presentation. I just had one question. You only talk about pushing data to the cloud.
Yes.
Why are you not talking about on-prem DVC implementation as well?
It's because we usually focus on the cloud, but we do on-prem too. So like if you're working with some type of healthcare data or biotech stuff, we work with on-prem.
So on-prem is also possible.
On-prem is also included. Yeah, I guess that's it. Thank y'all for coming and sticking around.